Hello and welcome back to Geometry. Today we will cover section 1.3, distance and midpoints, and complete the guided notes. Our first step is to look at what we'll learn. Here we will skim lesson 1.3, predict two things that we expect to learn based on the headings and the key concept box. So let's just scroll right on through. Look at the headings here. We have distance between the midpoints, or distance between 2 points, excuse me. So I bet we'll learn something about distances. Key concept says distance formula, though on a number line. And there's some new terms there. Key concept distance formula in coordinate plane. So let's summarize here. I already see we will probably find distances using a distance formula. Okay, let's see what else we can find. Midpoint of a segment, midpoint formula on a number line again, and midpoint formula on a coordinate plane. Okay, so same kind of deal. Now we're going to find midpoints, whatever those are, using a formula on number lines and coordinate planes. And we could also include that last bit even up here. So I'm going to very lazily duplicate that there. I just need to re-add the word on number lines and coordinate planes. Okay, which takes us to the vocabulary section. So let's start reading and looking for new vocabulary terms. Distance between 2 points. The distance between 2 points is the length of the segment with those points as its endpoints. The coordinates of the points can be used to find this length. Because segment PQ is the same as segment QP, the order in which you name the endpoints is not important when calculating distance. So my definition I have written here, length of the segment between two endpoints. Take a look at the distance formula on a number line. The distance between 2 points is the absolute value of the difference between their coordinates. So if P has some coordinate x sub 1 and Q has some coordinate x sub 2, distance PQ equals absolute value of x sub 2 minus x sub 1, or absolute value of the quantity x sub 1 minus x sub 2. See the example in part 2 of this video. To find the distance between 2 points A and B in the coordinate plane, you can form a right triangle with segment AB as its hypotenuse and point C as its vertex as shown. Then use the Pythagorean theorem to find distance AB. And this is a lovely example and a lovely explanation of the origin of the distance formula they will give here in a second. However, you might not be familiar with the Pythagorean theorem. So here is a quick reminder. Recall that the Pythagorean theorem is often expressed as a squared plus b squared equals c squared, where a and b are the measures of the shorter sides, legs, of a right triangle, and c is the measure of the longest side, hypotenuse. You will prove and learn about other applications of the Pythagorean theorem in lesson 8.2. And that is where we will study it formally in this class. So if you already know the Pythagorean theorem, which is fairly likely, you can use that as an aid to help you check your work in this section. But it is not necessary to complete the work here. But notice what they've done is they've taken that Pythagorean theorem setup and they've noticed, hey, the distances for the two legs of those triangles can be found as we did with the distance on the number line. It's the absolute value of the difference there. Of course, squaring an absolute value is going to make it positive anyway, so we don't really need the absolute value symbols, and we'll just take the square root of both sides to resolve that final distance of the diagonal portion. This gives us a distance formula for points in the coordinate plane. Because this formula involves taking the square root of a real number, distances can be irrational. Anything that is not a perfect square number will give you an irrational answer. Recall that an irrational number is a number that cannot be expressed as a terminating or repeating decimal. It's in the name. It is not a ratio. There is no fraction, perfect fraction form. So let's put that all together. The distance formula in the coordinate plane for P having coordinates x1, y1, and Q coordinates x2, y2, then distance PQ is the square root of quantity x2 minus x1 all squared plus quantity y2 minus y1 all squared. Note that the order of the coordinates within each set is not important, and neither is, of course, the order in the addition there. You could put the y coordinates first if you really insisted. See example 2 for that in action. What's next? The midpoint of a segment. The midpoint of a segment is the point halfway between the endpoints of the segment. If x is the midpoint of segment AB, then AX equals XB. That is to say, distance AX equals distance XB, and segment AX is congruent to segment XB. You can find the midpoint of a segment on a number line by finding the mean, or the average, of the coordinates of its endpoints. So here we have the definition of midpoint, the point halfway between the endpoints of a segment. How do you find the midpoint on a number line? Use the formula for the mean, the average. If segment AB has endpoints x1 and x2 on a number line, then the midpoint M of segment AB has coordinates x1 plus x2, all divided by 2. And there's an excellent real-world example there, and an alternative method. I encourage you, after watching part 2, where I go through this problem, to come back to this alternative method of solving it there. You can also find the midpoint of a segment on the coordinate plane by finding the average of the x-coordinates and of the y-coordinates of the endpoints. I know this diagram has a lot going on, but let's try to break it down. They have noticed that this point P has coordinates here, x1 and y1. This point on the end Q has coordinates x2, y2. And then if you look along those axes, what we are finding is the midpoint on a number line between x1 and x2 is the average of those, and between y1 and y2 is the average of those. And then when you line both of them up, you get the coordinates of the midpoint M, x1 plus x2 over 2, comma, y1 plus y2 over 2. And again, the order of the coordinates of the endpoints is not important. But what is important is the order x first, y second. That is how we always do coordinates on the Cartesian plane. You can also find the coordinates of the endpoint of a segment if you know the coordinates of its other endpoints and its midpoint. This is a natural algebraic extension. Given two things, find the third. Well, what if I give you the first and the third? Can you find the second? So it's a little bit of working backwards there. See part 2 for that example to walk through. And always do check your graph or make a quick sketch for reasonableness. Okay? If you end up with, especially when you're dealing with negative values here, if you suddenly end up with a point that is in a completely wrong quadrant there, you'll know you messed up somewhere. And you can use algebra to find a missing measure or value in a figure that involves the midpoint of a segment. Since we know by definition of midpoint is midway, each half is exactly half, so those two pieces will be equal. So that gives us another way to create an equation that we can solve. And now, any segment, line, or plane that intersects a segment at its midpoint is called a segment bisector. In the figure at right, M is the midpoint of segment PQ. Here is PQ vertically there, midpoint M, marked as such. Plane A, segment MJ, and line KM, and point M are all bisectors of segment PQ. We say that they bisect segment PQ. So bisector is the noun, bisect is the verb. A segment bisector here, a segment, line, or plane that intersects a segment at its midpoint. So there could be an infinite number of bisectors. Each contains, if it contains the midpoint of a segment, it's a bisector. And on the following page, there shows a construction process. Remember, construction is with compass and straight edge there based on matching distance. I'll let you take a look at that. That is not something we'll be doing in class together, but perhaps at a later date as part of an activity. But that brings us to the end. So this concludes the vocabulary portion. Let's go on to the vocabulary link. Midpoint can have non-mathematical meanings as well. Look up midpoint in the dictionary. Explain how the English definition can help you remember how midpoint is used in mathematics. I have gone ahead and done this ahead of time. So here is midpoint in the dictionary, a point at or near the middle of or equal distant from both ends as of a line. Or definition 2, a point in time halfway between the beginning and the end as of a process, event, or situation. Okay, so this will help us remember because it means a point in the middle or halfway reminding us the segment is divided into equal halves. All right, on to the main idea. Now, distance between 2 points. We're going to fill in the organizer for the distance formula on a number line and a coordinate plane with line segment AB and points x1, y1, and x2, y2. So overall, the distance formula for anything, let's look at number line first in symbols. So let's go back to where it was first. Given distance formula on a number line. This is for, let's see, AB. So distance AB is equal to absolute value. On a number line, we'll just go with x. We'll assume a horizontal number line. x2 minus x1. How about in words? Is the, let's take a look up here, the absolute value of the difference between their coordinates. I'll go ahead and highlight that there. Zoom in a little as I copy it down into this admittedly small box. Absolute value of the difference between coordinates. And what about distance on the coordinate plane? That formula is found here. In symbols, our distance AB would be equal to the square root of quantity x2 minus x1 squared plus quantity y2 minus y1 squared. In words, this one's going to be a little trickier since they are not provided. So I know it's the square root of the sum of squares. So I'm going kind of the opposite way you would actually process this algebraically. You would, to actually compute these, once you fill in the numbers, you would do the subtraction first, then you would square, then do both subtractions, then square both, and then add them, then square root. So I'm going to describe that in the opposite order. It would be the square root of the sum of the squares of the differences of the coordinates. Of the differences of, I'm going to say, respective coordinates. I do need to somehow note there that it should be the difference of the x coordinates and the difference of the y coordinates. So differences of the respective coordinates. That's quite a mouthful. Stick with the formula there. Midpoint of a segment. Let's model the solution to find the distance between the points on the coordinate plane. Use the line to show your calculations round to the nearest tenth if necessary. All right, so let's go to midpoint. This looks like on a coordinate plane, so let's have that up for reference. On the example given, point K, we'll call that our first point. So we'll label this as K over here, and we'll make this one L. K is at, let's see, 1, 2, 3, 4, 5, negative 5, comma 3. And L is at 1, 2, comma 1, 2, 3, 4, 2, comma 4. So then KL, the distance KL, that's what this would be suggesting here. We're not finding distance. We're looking for the midpoint here. All right, so we're going to ignore this and call it M. M would have the coordinates. Use the line to show your calculation. Model the solution to find the, no, it says distance between the coordinates, but that's definitely the heading for midpoint of the segment. Book. Okay, all right, you say so, book. You know what, let's do both. Let's just do both. KL, distance, square root of the square of the differences. X2 is 2, X1 is negative 5, subtract negative 5 is plus 5, square. Add, parenthesis, Y2 is 4, subtract Y1, 3, square. Square root of 2 plus 5 is 7 squared. I don't really need the parentheses anymore. 4 minus 3 is 1 squared. 7 squared is 49, plus 1 squared is 1. So this is the square root of 50. All right, there's what they asked for. However, the heading definitely says midpoint of a segment, and we haven't done any midpoints here. I think proper notes definitely need to have the midpoint formula as a reference here somewhere. So x1 plus x2 all over 2, comma, y1 plus y2 over 2, parenthesis. So then our midpoint here is going to be, now I've scrolled too far, I can't see the numbers. Right there. So 2, nope, they're in reverse order, right? So I did the -5 first plus the 2 all over 2. And this was the 3 plus the 4 all over 2. Let me double check that. -5 plus 2 and 3 plus 4. Yes, I agree. Which makes -5 plus 2 is -3 over 2, and 3 plus 4 is 7 over 2. And I'm just going to leave it as improper fractions. That is generally my preference. Okay, and then that takes us to the end. There is no summary or helping you to remember for this section, which means this concludes the guided notes for the entire section 1-3. Come back for part 2 to complete the example problems from the section. So long, farewell, enjoy the rest of your day.